the right time, I guess, to start this session because my funny accent already kind of, like gives it away as well. I'm from the Netherlands, so we have a 6-hour time difference. So it should be 2:45 right now, which is a great moment to talk about performance on Windows Phone devices. So thank you very, very much for coming to this session. I know it was an incredible walk to actually go here to this building. I left this morning at 7 o'clock from the hotel, and I just was here, like in time. But hopefully, if we're talking about performance, it's not going to be my walking performance or something, but hopefully it's going to be a little bit better there. And we're going to talk about Windows Phone and performance. So first I'm going to talk about performance in general on devices and our mindsets on devices. Then we're going to talk about how to identify a number of performance issues on Windows Phone. I'm going to show you a couple of demos. I'm going to use some real devices. And once we have, identified a number of problems and maybe came up with some solutions for that, we're going to move on. We're going to go into multi-threading and why that sometimes is very, very helpful in order to give the end user a better feeling of performance. And finally, I also want to take a look at Mango, and especially I want to take a look at the new profiling tools that we will get when Mango is going to be released. And now it's kind of funny, I think, if you're thinking about people using computers, we're all, kind of used to the fact that you sometimes have to wait a little bit until an application starts. Sometimes you have to wait a little bit longer if you want to boot the operating system. But if we're using a phone, it's a completely different story. We want immediate on a phone. We want immediately to be able to do whatever we want to do. And it's kind of unfair because that phone is battery powered. It has a slower processor than a typical desktop machine, and still we as end users, we just expect more from that phone. We expect a better response from that phone. Typically, I compare it to a light switch, like a phone user handles the phone as if it were a light switch. So if you switch on the light, it immediately should, turn on, and not 30 seconds later or something. And the thing is, Microsoft alone cannot make it cannot be held responsible for a great or a bad performing phone. We're all in this together. So our applications will, give the end users a great or a worse experience depending on how our performance is going. Because the hardware itself is wonderful. I mean, all these Windows Phone 7 devices have really good hardware. They have fast processors, they have a separate GPU, they have enough memory, so that's not a problem. However, if you're, creating applications that are not too friendly regarding performance, well, you have to think about, for instance, things like, hey, how am I data binding to objects? Am I going to use a lot of converters to convert one data format to another format while binding data? Because that's a performance influencer. How about those managed code features, which we all love, like a garbage collection, just-in-time compilation? Well, if a garbage collection occurs at the wrong moment, it would give your end users probably a bad experience. So what can we do about those? What about writing to isolated storage? That's another one that is very, very important. And isolated storage, being flash memory, is not the fastest type of memory that you can write to, especially. And there is quite some difference between different devices, even. So it's always good with, if you're looking at applications from a performance point of view, to at least think about those operations, writing to flash, data binding, complex items, stuff like that, to do that as little as possible. And actually, I think if you're developing for devices, there is this one little motto that I have in life anyway, that's don't do anything unless it's absolutely necessary. And if you think about that mindset for phone applications, then you're probably going to create some great performing applications. So don't use, animations because it's fun to show animations. Don't show too much data to a user. Be very specific in where you want to guide the user and do that as, optimized as possible. So less is more is definitely true for developing applications for a mobile platform. And it's very, very important, actually, to think about performance from day one. I've seen too many projects. I have actually worked on too many projects as well, where we were, adding some great functionality, and even more functionality and more functionality. And at the last day before shipping, well, we got all our bugs away, and then my boss came to me and said, like, well, it's kind of cool what you did, but can it be faster? Why does it take, why does it take 500 milliseconds for one screen to disappear and another screen to come up there? Why didn't you think yourself about things like that? Well, it's kind of hard if you're going to ship to then solve performance problems. So it's very, very important to start from day one to think about performance. And it's also very, very important to measure performance. And I know that that's a very, very tough thing to do, basically. And what I mean with measuring performance is come up with some numbers. Specify, for instance, what the maximum allowed time is for your application to start up. And come up with some fake numbers. I don't care. But say, let's say, like, my application should start within 1 second. If you have that number, then at least you have something to compare your application against through the development cycle or through your environment, through your entire development cycle. Then, if you add functionality and all of a sudden my application starts way slower, at least I probably only have to, go back and evaluate the work I was doing over the last day or over the last week, and hopefully that's easier to solve regarding those performance problems. Also, if you are, performance aware, you need to test frequently, each and every day, a couple of times, just make sure that each time you add a new feature, go through your whole process of testing your application for performance. That also ensures that if you have some regression, if all of a sudden your application becomes running slower, that again it's way easier to pinpoint what kind of problems you're going to have. There's a very, very important thing to keep in mind. Device Emulator is a fantastic tool to help you debug your applications, but the emulator performance is nothing compared to a real device performance. Even though the bits on the emulator are exactly the same, the emulator itself is hosted by a Windows operating system, and the behavior of that hosting operating system is simply different from the behavior of Windows CE, the operating system under the hood of a Windows phone. Apart from that, a desktop machine, a typical development machine, probably has, processors faster than 2 gigahertz and probably some multi-core environment. Maybe you're using an SSD drive or something. Well, this thing runs on a 1 gigahertz processor. It definitely doesn't have a real SSD drive. It has way slower flash memory to actually write data to. So very, very important to test applications as far as performance is concerned on devices. I mean, that's the real thing that you need to definitely do. Also, make sure that you test against real scenarios. So, for instance, this setup is like an unreal scenario. Typically, if I'm developing software, it's not on a stage. It's also not in a very, very wide room that I have continuously, to have a little eye contact, to move my head like an idiot continuously. And I have a network, believe it or not, thanks to this wonderful wire, that's just very, very fast. And probably when I'm going to run my application, we're going to get an exception. And the exception is more or less saying network connection too fast. Well, in reality, what I probably will have, if I'm using a mobile network for my data connection, is that network connection is very slow. And then if I just want to download, let's say, the internet to my device, it's going to take a while. So think about what you're going to do, how much data you need from a cloud service, and try to limit things, but always, always test against realistic scenarios. Also make sure that you're not running attached to Visual Studio. Detach everything, run release mode if you're really doing performance tests. And I know we don't have too many tools right now to evaluate performance, but you can always use a stopwatch, which is a built-in timer in Silverlight anyway, a built-in class, that can give you at least timer ticks, so you can have indications, if you store that locally temporarily, about how well your application is performing. Now, performance itself, and we're talking about Silverlight applications here. I should have said that probably at the beginning. So I'm not talking about XNA framework game type applications. Just I'm limiting myself to Silverlight-based applications for the phone. And performance there is influenced by many, many things. believe it or not, but even if your application is, in your opinion, a single-threaded application, that's not the case. It will execute multiple threads depending on what kind of functionality you are actually running inside your application. The other thing, think about how complex the UI is that you are creating. And initially, probably many UIs don't even look complex. Let's say that I'm going to create, like a little application. The application has a little picture box or has a list with a few pictures in there, a little description, maybe some additional information. So per list item, I might have 3 additional child items that I'm going to display. Well, guess what? This gives me tens or maybe even more of individual UI elements that needs to be rendered by the operating system. So thanks to the fact that I'm using a list box to show a collection of data, all of a sudden I have this huge stack of UI elements, and they will all help degrading the performance of my application. So you have to think about that. Networking, slow network connections, very important to deal with those properly, because there's this weird thing about performance. Some applications that I'm trying out, I'm thinking like, whoa, that looks pretty good. That's a decent application. And then, if I'm going to look like what that application really is doing, it's maybe showing me a splash screen. I am kept occupied by the developer of that application as an end user, and that gives me a good feeling about that application. Some other applications might not do that splash screen or might not implement, like some functionality on a background thread or something, and immediately I get a bad feeling about an application. I don't know how that is with you, but if I'm, like running on a conference like here and taking a look at the newest Windows Phone devices, what I'm always doing is go to a booth, start one of these phones and play with scrolling. Scrolling is my first indicator on performance of a device. The faster the better. Not that in my daily life that I just want to, just spend time scrolling as fast as possible, but it is a clear, simple indicator of how well an application is performing. So those are the things I'm doing. So inside my own applications, I better make sure that at least scrolling functionality is pretty good. So, yeah, scrolling, very important. Now, I already said that each and every application, Silverlight application, has multiple threads. There's one very, very important thread, and that's the UI thread. That's the thread that's the owner of all our UI elements. And that thread should be kept as silent as possible. The minute you are executing a lot of code on the UI thread, it will degrade the overall performance inside your application. So try to be idle as much as possible on that UI thread. Or in other words, if I'm doing long-lasting operations, let's say I have a button inside an application, there's a click event handler, and immediately straight on that click event handler I'm going to execute some code, and that code is going to last a couple of seconds or something. Well, if I would do that in a while loop, it would simply mean that I effectively blocked my UI thread, allowing or disallowing anything else that needs to be going on for user interface updates, for instance, they will be blocked. They will not happen at that time. So that's very, very bad. Another thing, since we are multi-threaded, we have a graphical processing unit. It's very important to keep that graphical process unit, so the GPU, to keep that as much occupied as possible. If we do that, then at least we have, more resources available on the UI thread. And each and every time you have long-lasting operations, and I do realize that your application will become a little bit more complex because of that, but think about, can I spin that off to a separate worker thread and just, maybe set an event once my long-lasting calculation has been done and the UI thread then is capable of updating my user interface again. So those are just simple things. The real things that really are, that really matter for good performing applications are some of the cooler UI controls. Like a panorama control is it's a very cool control, if used wise. But even Microsoft was at some time saying like, hey, make sure that you're going to use these cool UI controls that we're having if you submit your application to Marketplace. We might even focus more attention to your application. Well, that's not the smartest thing to do, because you want to use those controls when they're needed. So a panorama should be, like sort of the front cover of a beautiful glossy magazine. So you have hopefully, like maybe 2 or 3 panorama items. And if you need more information to be displayed to the user, get out of that panorama control and maybe make use of a pivot, or maybe make use of just an ordinary list box or something. Another thing is, there's a huge difference, even though functionality, from a functionality point of view, they look kind of similar, but a panorama control and a pivot control have a completely different behavior. Panorama initializes completely and only then will be displayed. So if you have a really huge panorama with many items in there, then it's going to take a lot of time to actually initialize, and you're immediately using up a lot of memory. A pivot control is a little bit smarter. It just makes sure that the pivot items left and right to the one that I'm displaying, well, those will be loaded in memory, the rest not. The rest only gradually when I'm scrolling through that pivot. Very, very big difference in behavior, and also a very big difference for an end user in their experience in your application. If you're making use of images, think about the size of the image. If you're just downloading an image, maybe like assigning it to an image control by passing a URI or something. If you're doing that, what we try to do is decode your image at the largest resolution, so at the native resolution of that image. Now, if you're only displaying a tiny little thumbnail inside your application, why don't you decode that image yourself? And because in that way, the image size is going to be smaller, decoding is going to be faster, you can store more images locally on the device, and the end user, again, has a way better experience. So think about things like that. If you're using a list box, list boxes today make use of a virtualizing stack panel. That's very cool, because what that means is that we don't keep the entire list box in memory, but we keep like 3 pages of data, at most, like 20 items or something, in memory. And if the user scrolls up, we're going to lazy load additional items for the user. And you don't even, you don't even have to be aware of that as an application developer. But what if I only have, like maybe 100 items or something? It might be worthwhile to, instead of having a virtualizing stack panel hosting a list box, to just have everything in memory, because then scrolling is a real rapid experience for end users. So you continuously have to think about what kind of functionality am I providing to the user, what should the performance idea for that end user be, and how should I implement a particular piece of functionality to get the best performance out there as possible. A classic one, and I used to talk a lot about managed code development in general, and then the classic one was always string versus string builder versus string concatenations. Well, we have a classic one in Windows Phone as well. That's the progress bar. And usually, I'm showing a progress bar when I'm running a long-lasting operation. I'm showing it indefinite. And guess what? One of the most important performance killers is the progress bar, because it renders completely wrong. It occupies the UI thread for a long time. So that's a very, very bad control to use. Now, there is a solution these days by making use of the Silvernet toolkit, or going to Jeff Wilcox's blog. He created a performing progress bar, a performance progress bar, which behaves way better. It's still a control that still is heavy on using resources, but at least it's not occupying the UI thread anymore. And I'm going to show you in a second a sample of how dramatic that progress bar actually is. So if you think about progress bars, you need them because you're going to tell a user that something is going to last longer. Well, what you don't want to have is end up in a situation where it's even going to take longer because you're telling the user it's going to take longer. That's kind of a ridiculous thing, isn't it? Another thing, and my demos will be full of this stuff, think about times when, if you're running animations, think about the fact whether or not that animation is visible. There are situations, especially in a pivot or in a panorama control, if you are running animations and if the user is sliding over your UI control, well, if he's getting that animation that is running, if it's becoming invisible for the end user, it would be kind of cool if that animation would actually stop. If it's not stopping, it will not update the screen because it's not at that moment visible on the screen, but it's still doing all the calculations in order for it to be able to update. So make sure that you know if you have a panorama or a pivot when a certain item is visible for the user or not, and only then enable or disable animations. Also, if you want to hide UI elements, make sure, especially in an animation again, make sure to not use the opacity. By setting opacity to 0, effectively what you create is an invisible control. But the invisible control, it will not be rendered, but all calculations for it will still be done if there's an animation active. By just setting the visibility property, all those calculations will not be executed anymore. So that's something important too. If you're using a Bing map, for instance, do you need the full functionality of the Bing map control, including zooming in, zooming out, and all that good stuff there? Because if not, maybe it's making more sense to call out to the Bing map service and just through a REST interface, just get some static maps instead of all the dynamic maps with which I basically can, like travel all over the world. And string versus string builder, well, I think, we hardly should have to discuss that, but it's still making a difference. If you're adding a number of strings together, make sure that you're going to use a string builder. If you are using event handlers, make sure that if you have an event handler that refers to another method in another class, make sure that if you don't need that event handler anymore, to unhook that event handler. To just make sure to, null that event handler out. Because if you're not doing that, then you are maintaining links to live objects, meaning that the garbage collector cannot collect memory that it was supposed to be collecting. And that just means that your memory footprint is growing and growing. Because of the fact that your memory footprint is growing, each time a garbage collection has to occur, we have to travel through a huge stack of objects that cannot be released because of the fact that we are holding to them because we were not unsubscribing from event handlers. So that's another one that you have to really be aware of. And I know this is, like a lot of information without too much practical samples right now, but we're going to go to those in a minute. So if we're measuring performance, make sure that you do that frequently, that you do that on a daily basis, and that you come up with some numbers, come up with that start time for an application. My application should be up and running within 1 second or something. Make sure that you're not running on the emulator for performance tests. What you can do on the emulator, which is still very cool, is you can sort of get trends of performance. So from one run of an application to another on the emulator, well, if the performance degrades a lot, then chances are pretty big that that's the same on a real device. But don't use emulator statistics or emulator measurements as real performance figures, because they're simply not. So those are, just simple rules of thumbs. So let's just solve some performance bottlenecks. And for that, I need to do some complex switching here, I guess. So now it's going to be ridiculous. Now you're going to find out that I'm not, having a technical background at all. But I think what we're going to do is just create a new application. The goal today is not to ship this application to Marketplace, but I just want to, create a cool little new application. To create a new application, I'm just going to create a new project here. It's going to be a Silverlight application, Phone App 1. It has a wonderful name there. I like it. It's going to target Windows Phone 7. And let me do some cool UI design here. So let's say, well, maybe a button. Not a bad element to have. Maybe I'm going to double click this. And what I'm going to do here is do the old message box showing something like I am clicked. How hard can it be to develop applications? Not really, right? I mean, it's all so simple, this stuff. I have a full functional application. So let me deploy. Well, let's go to the device emulator. Why not? Because I just told you that performance, you should never take a look on the emulator, so it's a good idea to make use of the emulator here, I guess. So the emulator is loading. I should have done this before, so we're waiting, you know, like an additional minute. But hey, this is running on a desktop. I accept it that I have to wait a little bit. It's not a phone, it's an emulator. So who cares, right? Well, I do, because I have to speak through that time, because I'm so nervous if it's getting silent or something. But that's the only thing. Ah, there's an application. Well, it's not the application I was looking for, so that's too bad. So let's go back and let me really go run this application. I'm just going to start debugging from here. Take a look at the emulator. Ah, did you see that? What a cool screen. There was a little clock with a background. People from Microsoft have told me that if you ever show that in public, the splash screen police will find you. So I'm not sure what that really means, but it sounds like a threat. So what they're saying is we should never, ever, ever make use of the default splash screen inside a Windows Phone application. Many applications still do. And if they don't want us to use that, why do they ship it to begin with? Well, I don't understand. But so the idea is that instead of making use of that splash screen, what I should do is maybe come up with my own splash screen. Not a bad idea either. So what I'm going to do is I'm going to terminate my application. I'm going to borrow a splash screen from another app. Let me see. Should have one here. Cool. I'm going to... what am I going to do? Help. Okay. Let me select everything here. Maybe copy. Go away. I'm going to add that splash screen to this application. Control V, cool, save it, and we're going to execute the application again. So I'm going to start debugging here. Start a new instance. It's kind of cool, but I mean, I just spent an enormous amount of time to create a really cool splash screen, and it's gone within half a second or something. So now I need to come up with a solution here. And this, unfortunately, is the painful truth. People are asking about this on news groups. They're saying like, hey, I have such a cool splash screen. How can I make sure to display it longer? I'm going to reveal the secret to you here today. So what you can do, for instance, is the following. I can go to my app.xaml here. And somewhere there is this launching event. My favorite activity. Cool. So, let's deploy again. And hopefully everybody's happy now. See, I mean, my end users are going to be happy because they see this smiling weirdo, and here's the application. Well, how cool is that? Never, ever, 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 never. Because then I'm going to be the splash screen police and that guys, and I know how to find you guys. So don't do something like this. It's silly. Instead, what would have been a way better approach is the following. And that's it. I mean, now I'm going to get really serious about splash screens for the next 1 minute or so. I'm going to zoom this to 100%. It's going to be a little bit hard right now to see, but that's okay. I'm going to start this application. We're going to forget about this splash screen. I'm going to remove it again. But instead, what I like to do is go to one of my favorite tools. Cool. I'm going to create a snippet of this thing here. And I was at 100% there, right? So what I'm going to do now is I'm going to copy this thing here. I'm going to say like, hey, I'm going to change my splash screen again. Goodbye, Maarten. There we go. I'm going to save this. I'm going to exit this. I'm going to make sure to forget about this. Let me just terminate that application and give this thing a screen fit again. I love low resolutions for display purposes. Not. And let me deploy. So here we go. Now, you did see that my screen dump was not correctly here, and I should have been aware of that. So if I'm starting it again, you see that there's this little bit of that animation or of that cartoon before. That was not intended, but what was intended is the fact that, hey, if I'm taking a screenshot of my main form and use that as a splash screen, then there are several things I can do. First off, an end user has an impression that the application starts very fast. What I could have done to make this better is maybe, like not show the title or the page name and only let that appear once the real form has been loaded. So after the unloaded event, the real page would be visible. In this way, though, my end user gets a very fast impression. Now, if I need to do some additional initialization, what I could do is, by just having this simple splash screen, as soon as possible in the loaded event on my main page, I can maybe fire off another thread and do some real initialization. And since I'm out of that static JPEG image that makes my splash screen anyway, I can already transmit progress information also to the end user. So that's an idea. Another idea is if you don't need it, and like this application, kind of like the application, but it's so fast, it's like a great performing application, it's ready to ship, but maybe I don't even need that splash screen. Well, guess what? If you don't need it, go away with it. If I'm running now, see, basically the same experience, except for the fact that I don't have an animation, an in-animation that was caused by that splash screen. So maybe this one is even faster. So the only thing I want to say is, indeed, don't show that little clock, that default splash screen. Don't show that ever in your applications, because it just proves that you just didn't run the last mile, like to make your application really beautiful. At the same time, if you need a splash screen, don't think about some things like, don't make such a complex splash screen that you then are, like sort of wanting to show that longer to your end users. That's a very, very bad idea, but keep it efficient. Make a screen dump maybe indeed from an existing stuff. Having said that, let's continue with a little bit more demoing. Because now I am in the mood to demo. So what I'm going to run is another application. I'm just going to run it on the device. And once that's done, we're going to talk about it. So where is my device? It's definitely not there. It should be here, I guess. Ah, there we go. So let me just start another application. Here we go. I'm going to start an instance. It should appear here on this device, which I should have cleaned. Ah, splash screen. Same mistake, I'm pretty sure. And here we have a beautiful application. It's loading some data. Funny enough, it's starting to load data after the splash screen has been displayed. So I was wasting a long time, and then I'm going to start initializing. That sounds weird, but it's still true. I also had a stop loading. I already clicked on that stop loading button. Now that was hard for you to see, but there was hardly any visual feedback from that button. Let's see how my scroll behavior is. Oops, it's not too good. But hey, it's a real modern Windows Phone 7 application. It makes use of a panorama. It has all kinds of scrolling items there. It even has, like a little fun thing for my end users. But still, that thing is not, it doesn't perform that well. It has something where it says animation, it says hide. Well, let's keep that hidden. It also says help, and I'm not sure why. Here's a timer. So that timer is ticking. Cool. And here's a progress bar. Well, actually, it's not a progress bar. It's 15 progress bars. Because I like to do things, like the way they're supposed to be. And they're not, they're not really helping. So this is 15 progress bars stacked together. Because everybody at Microsoft saying, yeah, we have some issues with progress bar. And then, I'm still like, well, big deal. Well, it's going to be a big deal. I should have made 100 progress bars here. That'll teach them, but oh well. So this is this one. But I could also use a performance progress bar. Now, this is way smoother already. And I'm going to show you a little bit more about that, like why this is smoother and why this is better. But if I'm going away here, it has this little radio button, stop progress bar when invisible. That checkbox is kind of important because now, even though we don't see it, that progress bar is still, what is it? Progressing, I guess, or something. But, you know, like, and that's the reason why this scrolling behavior is so nasty. So if I'm not doing that anymore, and if I'm gone from that progress bar, now things are already a little bit smoother. This is something, yeah, I could test this and I could be happy with that. If I'm going back here, and let me set a few settings. Let me first enable the frame rate counters. Now they are completely invisible for you. The thing even has to refocus. But so I have to tell you this. I also am taking a look at the memory in use. And right now in this application, and remember that's important. Oh, by the way, this is not going to be the question to win this phone, what I'm going to tell you now, but it is important. It's also important to stay here because you have the chance to win this phone. But I am using 76 megabytes of memory inside my application. And 90 megabyte is a magic boundary because your application should be smaller than that. So I'm towards that end already. I'm also going to show redraw regions. And, well, okay, I can stop the progress bar when done. So what you can see right now is that, hey, each and every time my progress bar is updated, a lot of screen area, a lot of parts of my screen are redrawn. Because every time that color changes, all that part of the screen is redrawn. If I'm making use of a performance progress bar, that's gone. Because now, instead of redrawing on the UI thread, I'm making use of the GPU's render thread or compositor thread to actually draw that animation. That's the reason why this progress bar, or this 15 progress bars, are running so much smoother than the other one. Another classic one is not the timer. Another classic one is my animation. So let me just animate a little bit. Here we go. Look at that. Beautiful spaceship flying around my application. What you also can see is that, hey, all these things completely need to be redrawn each and every time. I'm occupying, again, my UI thread. If I hide them with my opacity set to 0, you can still see a progress indicator somewhere here. The UI thread's performance counter, it shows up red, meaning that that thread is way too busy. If, on the other hand, I change from opacity 0 to just visibility collapsed, then the system is way more in rest, even though I don't see that animation. So what that means is that this particular setting, where that counter turns up red again, it's occupying the UI thread in a completely useless way because I don't see anything. I don't see anything happening. So why do I even have to bother with this, right? So apparently, the runtime here determines like, hey, an opacity of 0, well, you might think it's invisible, but I better calculate where that controls in that animation need to be drawn each and every next time. And that calculation is just what we're seeing here right now. So not the screen update itself, but the preparation for a screen update will be executed. So this application, if I would ship this to my end customers, and of course it's a popular application, so what's going to happen is my end users are going to use this application. They're not aware that there's a cool animation here, but what they will be aware of that, you know, probably within an hour, my battery is completely drained because I'm doing so much work here that's unnecessary. So think about that one too. I'm going to solve a few of these issues, but before that, let's keep in mind that we are here in a memory situation of right now around 80 megabytes. I'm getting closer towards that magic boundary of 90 megabytes. So what I'm going to do right now, and this is the most scary part of this whole presentation. I'm going to unhook this device. And that was not that scary, though. Cool. The rest of it is going to be scarier. I'm going to close down my Zoom software. It's already pretty scary. Although Zoom is not asking like, why did you just terminate me? Thank goodness, could have been too. I'm going to hook up a null device, which hopefully doesn't have an empty battery. No, cool. I'm going to start Zoom. And I'm going to be one happy person if that, oh yes, that device is recognized. And apparently it is. Is it? Or was it? Okay, cool. Let me check some settings here because I want to make sure that this device stays on. Screen timeout, never. I like it. Okay, this device is running the next version of, how do we call that? No, let's call it Mango. Nice fruit. Let's call it Mango. And what I'm going to do is I'm going to do nothing. Remember, performance, don't do anything unless it's absolutely necessary. Well, the only thing that's necessary is actually getting this application on this device right now. So I'm going to deploy again. I'm going to start debugging on a Windows Phone device. Well, I hope I am. Yay, okay, it's working. Same application. Exactly the same application. I'm going to load a few items, a few DVDs. I'm going to stop. Same bad behavior, kind of. I don't see anything in that button. I'm going to go to my memory, frame rate counter, and instead of an orange kind of looking memory indicator, I now see a green one, and I have to check it. Oh, God. 49 megabytes of memory in use. And remember, a panorama control initializes completely. It loads everything before it's going to be displayed. So, by running on Mango, the same application, not recompiled, I didn't do anything for it, because it's still a Windows Phone 7 application. What I just got is, I just gained like 30 megabytes of memory inside my application. The reason for that is that the common language runtime has changed. It's more efficient in Mango. One of the things is that in Windows Phone 7 there's many objects, temporary objects, that were allocated that are not yet garbage collected at that time. And a lot of those objects are duplicates of something that already exists. In Mango, those duplicates are not created anymore. So that's the reason that we're saving a lot of memory. Now, this is not a typical application. This is kind of a stupid application, and it's doing some weird things with memory. So that's the reason why I'm saving so much memory right now. But typically, in any application, you could think about anywhere between 10 and 30% of memory usage that you're going to save by just running on Mango. Saving that memory also means that your application is going to perform better because there's less memory allocated. On garbage collections, there's less activity that needs to be executed. So there's many, many advantages of running on Mango later on. And of course, what you also see is that, hey, a Windows Phone 7 application is fully compatible. It will run. However, if you want to make use of specific Mango features, well, in that situation you have to recompile and you have to maybe add 1 or 2 statements in order to make use of those. Let me do a few things to this application though. So now I'm going to go back to my development machine real quick. I'm going to terminate the application. So I'm going to stop debugging. Because one of the things, and I'm not going to go through all of them because we would not have enough time for that. We would actually use up time for our party tonight, which we definitely shouldn't do. But what I want to do is at least take a look at my functionality as it is right now. So I'm going to go full screen in XAML here. And, okay. And one of the things I did inside this application is I have 3 different list boxes, and they all have their own data template. So I'm using data binding to feed those list boxes. They're all identical, more or less. There's a few differences, like here I have a thumbnail that's a little larger. Here I have thumbnails that are a little smaller. That's the only difference. On my initial panorama item, I'm just showing that first list box. On this varying items one, I'm showing a second list box. Not interested at all because it's just, like displaying the list box. It's making use of an items template. It's using data binding, all that good things. And what it means is that this list box is making use automatically out of the box of a virtualizing stack panel. It is getting as much memory as needed for 15 to 20 elements. It's going to reuse those graphical elements when we are, like scrolling down. In this one here, though, in this fixed items one, which has like an identical item template, but I'm adding a few pieces of XAML here. I'm just saying like, hey, my item panel, its template should make use of a stack panel instead of a virtualizing stack panel, which was the default. What this means is that for this third screen here, I'm just going to preload all information and I should be able to very, very fast scroll through it. So that's a big difference because of the fact that I added something. In my animation, or actually in that scrolling collection of planes that I'm having, well, those planes are making use of vector graphics, and the runtime is not automatically capable to incorporate the graphics processing unit to draw those graphic planes. But what I can do is kind of hint the runtime and just tell it like, hey, I know better. These little creatures here, you can treat them as bitmaps. And if you are treating them as bitmaps, you can execute updates for those UI elements on the graphics processing unit. So what I'm going to do here is uncomment this out. Okay, I hope. Oh, that was stupid. Let me see if I can recover that. Thank you. There we go. And I'm going to draw more efficient here. Like this. By just adding a cache mode as bitmap cache. My animation, I already said there is something here, that I'm going to set the opaque property. Very, very bad idea. But ultimately, I have many items here in this panorama. I'm even wondering if this is the right control here. So instead of that one, why don't I go ahead and do some find and replace? Let's do a quick replace because we're talking about performance here, right? So let me do a panorama and replace that with a pivot. I'll just do that in the selection. Oh, let's do all. Why not? 25 times. What you see is that, well, what you will see in the end is that, hey, now I created a pivot control. It still has that same picture there. The only thing is that that picture is now wrapped into one single page. Probably I don't even need that, which saves me a little more memory even, so I'm going to remove that background here. And there we go. And I'm going to deploy this again to the device. So let's take a look. I'm going to run. Let me start it. In debugging again. Boom, there we go. Hopefully. Hopefully I didn't make any errors there. That would be helpful. Ah, wonderful splash screen. I love that splash screen. And see, so this is looking a little different. Oh, and I just got an exception probably. Web exception was unhandled. The remote server thought that you were too fast. If you don't believe me, I can show it to you. Because the remote server sent me an email. In order to find that email, I have to really quickly go to my Hotmail account, but it's important, so let's see. It should be here. How many times do I need to do that? I'm going to go to my inbox. And this is the email. Well, this is an email I had this morning, similar email. It says like, our logs indicate one of your applications has exceeded the limit for queries per second. And that happens because of the fact that I'm now running on a pivot control instead of a panorama control. So what I'm doing, and that's the thing, this is a, like a web service that I can use for free, but instead of, like slowly initializing and asking some data, now it's like boom, 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 I'm retrieving data. Their suggestion is, this is a funny one, if you're talking about performance, why don't you build in a sleep in between calls there? I love it. That's the reason why I had to show this to you, So let's see how the application is doing for the rest here. So I stopped loading. Is it crashed? Oh yeah, it did. So I have to, well, actually it didn't crash, but I have to continue running here. Oh, maybe it did crash. It really crashed, so I have to restart it. And then make sure that I'm not calling out too many times to that service there. So I'm going to start a new instance. I'm going to immediately hit that button here. And once we're there, yeah, please stop loading. Stop. Oh, phew. Yeah, up and running. Cool. So the behavior of the application is, of course, exactly the same. I still have that nasty progress bar there. So let me get rid of that. I'm going to stop that. I'm going to enable my frame rate counter again. And now I'm using a little bit less memory still, like around 35 megabytes. The reason for that is that only the pivot pages next to the one I'm displaying were loaded. So if I'm scrolling through all of them, then eventually my memory will increase to that same amount that I had. Another thing, if we're talking list boxes, this is a very complex list box, even though you might not believe it initially. But what needs to be done here each and every time is that a calculation must be performed to figure out how much space there is necessary or needed for one of those individual items. What you can see is that those thumbnails are not spaced evenly. So the reason for that is that my text is wrapped, so if I have a long DVD title, it means I'm occupying more space. What this automatically means is that this is a big impact on the UI thread. The GPU itself and the render thread are not capable of finding out themselves how to render this. On this one, that's not happening. So here I have evenly spaced stuff because I'm just limiting the information I'm showing the user. This is way better performant. This is also a stack panel, not a virtualizing stack panel. If I'm running through it, and this is my typical test, right, that I would do at the booth. How is this running? Well, this is running cool. And note how never I see a black area appearing in my screen. Now, if I take this one, see the difference? It has to recalculate things, but also it's making use of a virtualizing stack panel. It's loading dynamically more information in when it's needed. And it's doing that perfectly in one direction, scrolling down. But scrolling up, it doesn't. So if you want to do that, if you want to make use of virtualization, you want to have a better experience, think about how you can probably, create that yourself. Because there are solutions for it, but they're not available out of the box. So those are a few important things here. Let's just continue with the deck, because I could talk for hours and hours about this alone, about this one, well, not about this application, but about the impacts in this application. And unfortunately, we only have 22 more minutes left. And this time, I definitely want to show you the profiler. So background processing, and we saw a little bit of examples there. Very, very important not to occupy the UI thread. But if you want to do something, a long-lasting processing operation, well, it's just better to make use of a background thread. What you can do is make use of a background worker in Silverlight or start a thread pool thread, execute your long-lasting operation, and think about a way how to call back into the UI thread once you're done executing that long-lasting operation. So your application will be a little bit more difficult, but your end user will definitely benefit from the fact that your application is more responsive. One of those items that has an issue with background processing is a web client. Web client is a remarkably simple class to call out to a web service and to return information from that web service. It's very, very simple. I'm just specifying a request, and I'm also signing up an event handler. That event handler will be called whenever the request or the response for that request has been received. However, in Windows Phone 7, there's a little bit of an issue with Web Client. No matter on what thread, so if I'm creating a background worker thread myself and I'm executing Web Client on that, no matter if I'm doing that or not, the response in that event, in that completed event that we'll execute, will always run on the user interface thread. No exception there. And I thought this was a big question I had, like why would Microsoft implement it in that way? And then I started thinking, like probably there was a software developer, just like I am, who thought like, I'm gonna make life for all those third-party developers out there, I'm gonna make their life easier. Because if I'm allowing my response, my web request response, to execute on any thread, and if those third-party developers, want to update their UI controls, they have to do something with a dispatcher, begin invoke method, and all that difficult stuff. Let me be a good Microsoft guy, let me make their life easier, I'm gonna run this on the UI thread. Great idea, I love it. Except for that moment when I thought like, hey, I wanna do a long-lasting operation, I want to do some calculations before I'm displaying information to my end user. So in my event handler that is called whenever my web request returns, I'm just first going to do some calculation and only then updating the UI. Well, the result, of course, was that my UI was frozen for 20 seconds because I had a lot of calculations to do. So something where a developer at Microsoft thought like, hey, I'm doing a good thing for the world, kind of bit him nasty. So in Mango, this is going to be changed and this is going to be fixed, and the web client will, or the web client will return on the thread on which you created it and not on the UI thread anymore. But it also shows how incredibly difficult it is to create APIs and classes in a framework for us to use, actually. And this is one little incident, but if you think about it, and really, I mean, this is something I mean so from the bottom of my heart, that I think that the folks who worked on the Windows Phone team, they did a remarkable job by creating something that is so usable for us. And, you know, like these tiny little things, we can live with those, I guess, you know. So let me just show you real quick how that web client operates right now, and well, I'm not even going to show the Mango stuff there. I'm just going to terminate this running application. We're going to take a look at that web client. Probably do that to the device emulator. It makes a little bit more sense here. So what is happening is the following. Let me just show some code here. So I have two web clients here. I created two different web clients. One of them, my download string completed event, I'm just creating a new event handler. And what I'm doing is just calling this method, meaning that this will always execute on the UI thread. I have a second one, a more efficient one, in which I'm again assigning an event handler. But that event handler, what I'm doing right now in this completed is I'm going to start a new thread as initial part of my event handler. And that thread will then execute any result that I'm having returned from my web client. Meaning I'm doing a little bit additional code, meaning that this particular string completed event handler will still execute on the UI thread, but the only thing it's going to do right now is fire off another thread. Now that's kind of an expensive operation, but not as expensive as the long-lasting operation that I'm doing to calculate whatever I want to do before updating UI controls. The consequence of that is, however, that if I want to update user interface components inside this particular thread, what I need to do is making use of begin invoke, because now I'm executing on a separate thread. If you see this in action though, so I'm going to just run this, starting a new instance. Oh, I hope so. Yeah, oh, that's the right thing to do. And what I'm having here is a little clock. That little clock is continuously running if my UI thread is not occupied. So now, I mean, there's plenty of time. My UI thread is nicely, let's say, in rest more or less. It's just waiting for me to retrieve a product. Now, if I'm retrieving a product, what you can see is my clock is stopping. That we are hitting a breakpoint here, that was not necessarily what I meant. But my clock temporarily stopped. If I'm doing that again, see, it's just pausing there. I cannot update my UI. However, if I'm calling this response in the background, and I'm now retrieving again a product, see that at least there's a little glitch there because of the fact that I need to create that thread. Well, that's a time-consuming operation, but the overall performance is better. Then another thing that performance-wise is very, very important is I'm showing again some data from a DVD, but just make sure that you only retrieve information that you are interested in, if you can. So if I'm just calling out this web service and get all kinds of properties about this particular item, I'm just, each and every time I'm calling out, I'm using 6.3 kilobyte. However, if I'm limiting that data and just only take the data that I'm interested in, then what you will see is that now I kind of halved the amount of data that is going over the wire. Again, getting a better performance, and also meaning that I'm just using less battery. So those are things you definitely need to keep in mind as well. Let's go back to the slide deck. And let's talk about whatever beautiful things we're going to get in Mango. Well, one of the things is, for end users, it's definitely nice that we're going to have fast application switching. It means that our application might not be tombstoned and therefore resumes way faster when the user switches between applications. Each application can join in fast application switching. The only thing you need to do for an existing application is you need to make sure that you test whether or not that application was tombstoned. So it's not an official demo, but I feel I need to show that. So what you need to do in your application, or what you can do in your application, and I just converted this Performs Today application anyway. So if I'm going here to my app.xaml.cs file, and if I'm taking a look at my application launching, what you will see in the pre-Mango time right now is that, if I'm taking a look at my activated event, because that's where I need to be, what you will see right now is that what I'm doing is I'm loading some application settings because of the fact that I came probably out of a tombstone situation. That's very likely, otherwise I would not have gotten an activated event. In the Mango time frame, what I need to do is if is this a Mango app? I am curious now. Looks like it's not. How can that happen? Oh, I didn't convert it yet to Mango. Oops. Oh well, let's do that. Upgrade to Windows Phone 7. So this is another step you need to do. Upgrade to Mango. Oops, I didn't say a version number there. It's getting late. I'm getting old. I don't know what. But and what we're gonna do now is for this application, we're gonna again go to that same method here, activated. And what I now need to do, this is the only additional code I need to add, is application, oh come on please. Is application instance preserved? If this is not the case, that still means that I'm coming out of a tombstone situation. Well, then I need to load my settings and do my initialization. If, on the other hand, the application instance was preserved, I don't have to do anything because all my data is still kept in memory for me. So these are the only modifications you need to do in a Mango application to join in fast application switching. Another thing is that it makes a lot of sense to start reading all information about garbage collectors that Jeffrey Richter wrote in the past about the .NET framework. Because right now in Mango we're going to have a generation-aware garbage collector, meaning that the pattern for garbage to be collected should be around very short-living objects. Each object that's going to live longer will be promoted to a next generation. The garbage collector starts off by first collecting only generation 0 objects, and only when it's still in a memory stress situation it's going to try and collect longer living objects, and so on, meaning that it's going to take longer and longer if we need to collect over multiple generations. It's just going to take more time. On the other hand, the idea of the pattern is that if you have short-living objects and you can garbage collect only those short-living objects, the tree that we need to walk through in order to garbage collect is going to be shorter, and therefore garbage collection is going to be way faster. So to know all theory behind it, I could, probably talk another day or two about garbage collection. We're definitely not going to do that, but read all that stuff that Jeffrey Richter wrote. I mean, it's fantastic background information on garbage collector for the full framework. We are not par with the full framework, but we are getting sort of towards that area. So very, very important to take a look at. And then we have something really cool, and it's so new that I still have to, get familiar with everything in it, and especially in interpreting results of it. But we have profiling capabilities in Visual Studio 2010 for Mango. So we have a full profiler, a memory profiler, and a code profiler. And they ship not just with the professional SKUs or something, but they're just part of Visual Studio 2010 Express for Windows Phone. So everybody will get their hands on the profiling tools. And what it's going to show you is visual information about possible, potential performance situations. And what they're also trying to do is interpret the behavior of your application and come up with a scenario of possible solutions to solve your bottlenecks in performance. So there's a lot of intelligence in the profiler. Now, of course, this is a beta build that I'm showing, and this is, I think this is the first or the second beta build where the profiler has more or less a reasonable stability. So here's my disclaimer. If this might crash, then, then it crashes, I guess. So what I'm going to do is I'm going to run an application on the device, but I'm going to show, to start off, I'm going to show at least Visual Studio. I'm going to start a new instance of this, or no, I'm just going to open a new project here. Let's see. This is showtime, indeed. We're going to talk about profiling. No, I don't need to save anything. And basically, my application is as stupid as my previous application, probably more stupid. But that's me. I mean, that's why people want to listen to these stories, I guess. To learn from my stupid application. So let me just start profiling here. Therefore, I go to the debug menu and I start from inside my debug menu a Windows Phone performance analysis. When I'm doing that, what you will see is like, hey, I get this question like, what do you want to perform your analysis on? Is it an execution model? Are you interested in code profiling? Or are you interested in memory profiling? With memory profiling, sort of a very, very intelligent way of the CLR profiler that we had in the Compact framework, for instance, for those people who did Windows Mobile applications. Now I'm going to start my application from inside this menu here. See, profiling is in progress. Here's my application. And my application has a little clock here. Oh, oops. It's running a little clock. And it has this little clock, and it also has a pause button here. It has a question thing. Ah, there's my planes again. And I can start playing them. And I can, like kind of hide this with the animation still going on. I'm going to terminate the application. This is an impossible task. Now I'm collecting data from the application. So I'm connected through a USB cable. I'm collecting data. The data was sampled here in my device. I'm just creating or copying that information to my development machine. That information is now parsed into a log file. You can already see that that log file is here created, profiling with the current date and timestamp. And here is some profiling information. Now, can I zoom this even further in or out? So we had a run, let's say, over 30 seconds. And if I'm now selecting, what you can see here is CPU usage, like what is the activity of the user interface thread? What is the activity in blue of the application itself? What is system activity on the CPU? So what you can see here is basically CPU activity divided in 4 different threads, being idle, UI thread, application, and system. I also can see the frame rates with which my UI is updated. And ideally, this should be as close to 60 frames per second as possible. So let me take a look now if I want to, investigate some performance problems. And by just selecting an area here, and that's the part where I said, hey, we need some time to learn to know what interesting graphics we are looking at here. And right now it's just a matter of playing with these tools to start and understand what they're showing. So what they're saying here is hey, I have a very high CPU usage on the UI thread. And there's a suggestion. Use functions option from the drill down menu to figure out which are most CPU bound methods. So I'm going to go to functions. I'm going to sort on the amount of time we are taking. And what we can see here is that there is some native function. That native function is taking up a lot of time. And there are also some functions with kind of a hyperlink on it. Well, these are functions that I wrote in this application. So, for instance, here is my main page constructor. And that's taking a lot of time. The reason it's taking a lot of time is probably because it's calling initialize component there. I can take another look at this by taking a look at a function call tree. So if I'm sorting again in the right order, what's going to happen now is that I can see where my constructor, for instance, why was it called? It was called because some native function called it. The reason that native function kicked in was because there was some reflection going on. So in my application start, what's going to happen is we're going to look for my Win main object or something underwater. And we're using reflection, apparently in a common language runtime, to come there. So you can see a lot of information there. Now, if I'm going to continue here, I was executing some graphics function. And what you will see here is an indication hey, there is a lot of invalidations due to animations of a cached visual. And they're saying my flame is cached as part of a visual grid, ship grid. So they're knowing already that, hey, I'm doing an animation, and that animation is causing a very bad performance inside my application. And what I now can do is, for instance, take a look at the visual tree at that starting point here. And if I then take a look at my drawing time, by just sorting that, what you can see is that things that are occupying a lot of time is this canvas here. And that canvas is the host of a number of animated ships, which each take a lot of time to draw. And you can drill down to each and every individual item of one of those animated ships. That's still my first animated ship with all its UI elements. And you can see how much time it's taking and how, hopefully, we can optimize information given the fact that we have this knowledge. And then we have the same thing there for my second animated ship. I think I would love to talk a week about the profiler, but I'm still learning to get a feeling for this information here. So hopefully next year at TechEd, there is this possibility to talk in depth about profiling. And since the tools are then definitely released, or better still, within, what is it? Within 12 days, we will have beta tools for Mango because Microsoft promised them before the end of May. So we're going to have that for sure, and that gives everybody the chance to start playing with profiling. So this is about everything I have time for during these sessions. I hope that, like my most important takeaways are performance is crucial, especially on devices. Our end users expect from our devices a way better performance than we typically have on a desktop machine. It's important to know what's going on in the hood of your application. It's just important to realize, for instance, like, hey, am I leaking memory? Everybody who says that managed code is not leaking memory is living in a fantasy world. You have to think yourself about things that you're doing. When are garbage collections needed? How about my graphical tree in a Silverlight application? Am I making use of complex animations? Or am I making use of large visual trees or something? So think about performance continuously. And the most important rule, don't do anything unless it's absolutely necessary. Another thing that I need to tell you is that if you don't have the tools, go to create.msdn.com today, download the tools, start playing with them. As you saw, you can start creating Windows Phone 7 applications, and by just converting them inside Visual Studio, there will be Mongo applications later on. Hardly any effort at all necessary. Mongo tools will be available, but last and not least, I mean, that's the most important thing. It's so much fun to develop for Windows Phone, and I hope you guys agree with me, and if not yet, then hopefully you're agreeing tomorrow. I have one question for you, and this is unfair. I know that already, so what I need to do now is I need an overview of the entire room. I'm sorry, but this has to happen. I'm going to ask a question, and somebody can win a phone. My question is the following. What thread is very important for performance? You, sir. Yeah, the UI thread. That's correct. I'm going to hand it over to you in a second. Thank you very, very much for your attention. We have to leave the room, but I'll be hanging around for questions, and hopefully you have a great party tonight as well. Thank you.